I mentioned earlier when we talked about the anatomy of the long bone that there are two major types of bone. There's going to be compact bone and there's going to be spongy bone. And in this, we're going to talk about the details of compact bone and touch upon the characteristics of spongy bone. So let's take a look at this diagram, and holy cow, what do we recognize? That's a good question. Let's look at the diagram that's in the upper left part of this picture, which is right under the term compact bone. We've already talked about compact bone. We know that there has to be a nutrient foramen, which allows blood vessels and nerves to enter and exit. We know about the end ostium, which is going to be the membrane that surrounds the medullary cavity. We're going to take a little chunk of that bone and expand it so you can see what's happening with compact bone. So if you take a look at the part of the diagram that's in the upper right, let's go over some of those terms. Well, first, you can see spongy bone and compact bone both labeled. This is somewhat misleading because when you talk about compact bone, you're going to be talking about osteons, but compact bone is not 2 osteons thick. It is probably thousands of osteons thick because you are talking about something that can be seen on a microscope. So we're talking about something that is way thicker than 2 osteons. That little plug that is sticking up from the rest of the bone is known as, the whole unit is known as an osteon. It is also, has also been called, it was originally named Haversian system. Havers, a guy named Havers, found it and he named it after himself, Haversian system. We'll use the term osteon because that's the most commonly used term these days. In the middle of the osteon will be the central canal. You can call it osteonic canal if you want. Central canal is easier to remember. Central canal will contain blood vessels, lymph vessels, and nerves. Around the osteonic canal, or the central canal, will be layers, which are known as lamellae. And you've seen that term earlier in the presentation. It's a fancy way for saying layers. So the osteon is going to have that tree ring-like appearance, and sure enough, those rings are the layers, which are known as lamellae. If you take a look at the little tiny dots, those are going to be osteocytes within lacunae. So let's move down to the picture that is at the lower right part of that diagram, where you can see the lacunae, which is that space or pocket in which osteocytes live. Now, when you look at the bone, whether it be spongy or compact bone, you will see those tiny, tiny, tiny little hair-like structures. Those are known as canaliculi. A singular is canaliculus. And I had a student one time ask me, can I remember it as canaliculi? And I said, that is fine, just don't write it on the exam, because if you do, I'm going to say, no, you may not. The canaliculi are going to be important because remember when I talked about the osteocytes and I showed you how they had those processes sticking off them? Those processes are going to be important because they allow for intercellular communication, and they actually are going to be routed through the canaliculi in order that these osteocytes can talk to one another. So again, the canaliculi provide routes for intercellular communication. So let's go back up to the diagram, or the part of the diagram that's in the upper right. I've already looked at the osteon and the central canal. You can see the periosteum is there, and again, the periosteum is going to be attached by Sharpie's fibers, which are not shown in this diagram. You will see additional central canals, and you will also see interconnecting channels in between those central canals. Those are what are known as perforating canals. You will also see them called Volkmann's canals, and that is Volkmann, think it's two N's, apostrophe S, because a guy named Volkman found them and named them after himself. Osteons are specific to compact bone. 100% of the time, if you are talking about osteons, you are talking about compact bone. Let me repeat that. When you hear the word osteon, you are always talking about compact bone. Let's take a look at the spongy bone, which you can see in the lower left part of that picture. You see the word trabeculae there? Trabeculae, when you talk about bone, are always associated with spongy bone. Always. They are those sort of flat plates or spicules or structures that give spongy bone its sponge-like appearance. Don't get misled. Spongy bone is not soft. People think, oh, a spongy bone is probably a little bit flexible like the dried out sponge. It is not. It is bone. Bone is bone is bone is bone is bone. It is hard. It is made up of collagen fibers surrounded by hydroxyapatite. It is hard. So here's a question for you, and I want you to think about this, and let's see if you can come up with an answer and remind me to talk about this when we're online. Why do we have two types of bone? Why aren't we all compact bone? Or why aren't we all spongy bone? Why do we need to have both compact bone and spongy bone? Think about that, and let's see if you can come up with an answer. This just shows you a micrograph of compact bone. You can see the central canals in the middle of those tree rings. You can see the small dots, which are indicative of osteocytes and lacunae. If you look really closely, you can see those tiny, tiny, tiny hair-like structures, which are going to be the canaliculi. You can see the layers, those tree ring-like looking structures, which are known as the lamellae. And there you have it. That is compact bone. Anything we have just gone over is fair game for an assessment. Yes, you need to be able to identify all of those components. More of the same. The C marks the canaliculi. The H marks the central canal. In this case, it would have been Haversian canal. And the L marks the lacunae, which houses an osteocyte. If you see something like L marked on an assessment, you need to tell me it is an osteocyte within a lacunae. You cannot just write lacunae, and you cannot just write osteocyte. You need to be able to tell me that osteocytes reside within lacunae. So the correct answer would be, if the question is identify this structure, you will tell me osteocyte within lacunae. This shows you the lovely relationship between both compact and spongy bone. So again, compact bone will be superficial to all bone, and you will have spongy bone within the middle. When you talk about spongy bone, especially in the long bones, you will find in adults red bone marrow within it. Let me repeat that. Red bone marrow will be found in the epiphyses of long bones. If you were an adult, you will have yellow marrow in the medullary cavity surrounded by that endosteum. And if you are an adult, if you're an adult. If you're a kid, you'll have red bone marrow. Remember that adults still need to produce blood cells, so we do need to have some access to, you got it, red bone marrow. So that will live within the epiphyses of long bones in particular. And as it says there, note the trabeculae in the spongy bone. There it is.